Alright, in this video I'm going to talk about a specific tool called Strace, which is very popular, and the whole and sole purpose of this particular tool is to assist you in debugging the clogging or discovering the underneath mechanism, whatever you are trying to figuring it out. So it could be see the underlying mechanism of the binary or program running or whatever. The main purpose of this tool is to assist you in debugging. Okay, the name of the binary is Strace, and it is a very popular tool, so everybody knows. So I have decided I'll take a quick pick on it, okay, just to show you a little bit of demonstration. So if you are not at all familiar with it, it might help you to get along with it, okay, and start experimenting. Okay, so without further ado, let me spawn up a terminal, okay, and let me go to a different space, and first of all let me zoom it so people can see it. So I have zoomed to the best. I hope people can see it. Okay, so let me start with first thing. You can call the Strace binary like this, okay, and you can provide directly. I'm just throwing a binary, a common. It could be anything. It could be ls, it could be cat, whatever. So let me start with cat. Okay, so if I wanted to see the mechanism underneath what is going on while I invoke cat, so if I press enter, see, it will show you the underlying mechanism, how the cat is invoked or used underneath. Okay, so you can see it call up with an argument, okay, execve, that's a common mechanism, and then its mmap is signifies the memory mapping of that particular stuff. Okay, there is a open at system call, access system call, okay, new fstat system call. How this going to, how it mapped its memory and doing stuff, it will show you like that. Okay, so if I go down, you can see what is going on underneath. Okay, it is very helpful. Okay, so now you can see you might not want to see it at once. Okay, so you probably thinking you could have stored this particular information in a files to later diagnose it or scan through it, so you could understand better what is going on underneath the skin. Okay, now you could do so easily. I'm sticking with a single example here just for the sake of the consistency. Okay, Trace has a -o flag, and if you give it a name, cat internals, okay, and then if you call in any binary or any program, okay, so it will store in that file. Okay, instead of spitting it out on the terminal, on the std out, okay, it will going to store it on a specific file. So if I press Ctrl C, and the tracing will be end and put all the mechanism in that particular file, if I wanted to see that cat internals, okay, see, here is your output what we have ran. So in a way you can capture this information underneath. You see the last line, killed by SIGINT, because I press Ctrl C. Okay, so it killed the tracing. Okay, Strace is basically traced underneath to find out what is going on, how it is operating. Okay, now this thing you can use several other stuff like this. Say for instance, if for some reason, so there is a flag called T, and you can extend the verbose. The -T means, say, like you saw, I stored that internal in a file, right, for later use. But when you do that, you want the timestamp to be attached with every damn single line it is outputting or accessing. So -T signifies it attached the timestamp with it. If you add more T to that, I'm using single T here. If I add another T or another T, so the verbosity level of the time stamping will be much greater. Okay, so I'm strict with the 1, and if I write cat, and if I do not, for the sake of this demonstration, I could have easily redirected it to a file like I shown you in the last step, but I want to show it to you in a std out, that means on terminal, to show you that how it looks like with a timestamp. Okay, see, look at the output, look at the leftmost side of the terminal. It outputted timestamp with each and every line. So it might help you if you're running a long running process and wanted to debug and wanted to have a look at it, and that process might be running for a long time, timestamping could help you. Okay, so basically, so it will, as I said, it can be used like that. Now you could also get a, instead of getting all these debugging statement at your disposal, and you probably get intimidated by looking at it very first time. Eventually, when your mind think, okay, I'm going to debug, so you'll start to absorb all the debugging statement coming with it. Okay, so instead of that, you probably want to have a quick look what is going on underneath. There is a flag -C, which nothing but summarize what have been verbosely shown previously. Okay, if I do cat, okay, to trace it with a -C flag, that means I want to see the summarized form of the debugging statement, where it's penned, how it is penned, how it is doing, right? If I do, and if I let it to run for few seconds to gather the statistics underneath, okay, so now if I have it probably run 5, 6, 7, 8 seconds. Now if I press Ctrl C, see, this is what you get with the -C flag of Strace. It simply summarizes the time, the seconds, user syscalls, error syscalls. Because this is a trivial example, so you won't get much UBL. In the UBL, in a sense, much more information in the output, whatever you are seeing. If you run against a complicated stuff, you might get lots of information, which essentially help you to debug the stuff if something clogged, or if something stuck, or if something misbehaving. This is an age-old tool, and everybody know, as I mentioned very beginning of the video, this is a popular tool. and every damn person out there, they're using it. I'm doing this video just for the sake of who probably heard about it and never use it, and never heard about those two category people, so they can get familiar and another, oh, there is a tool I can use to find out what is going on underneath. Okay, so there you find the similarity, right? There is other popular tools are there which I might cover in different video. So last but not the least, you can look at the man page, man trace, and it says trace system call and signals, and you can see they have given few examples. If you spend a little bit of time on this man page, your understanding and enhancement would get some sort of fillip. So in a sense it will help, and it's not a too long a page. So there are few flags are there. One popular stuff, you can see, you can follow. So the if is very important. Why I'm saying, because if you write a program and that program spawn a child, which is very common for forking, so Strace by default do not follow child, it only stuck with the parents. To follow the spawned process, you have to use follow, like we following the log file with hyphen. Similarly, if you mention the -f, it will follow the execution of the child too. So it will not stuck with the parent process only. Okay, so to follow the child process or forking process, you have to use -f. So you can give the events, different events are there with the -e flag, like open, close, open at whatever is showing. If you pass trace -e, then the library call, like open at, or whatever the nmap, whatever the system function it is calling, you can get how it is doing underneath that function. Okay, so it's very helpful. Okay, and you can certainly I'll show you one more final example, so it will help you. I highly recommend you to please spend some time, look through this man page, and it might take half an hour. I believe it will be worth of your time if you scan through it for dedicatively without getting distracted. So if you decide, it's a damn powerful tool. You could easily use it for the first debugging step. So, and it's been proven over the years, and people are using left and right to do all this kind of. There are popular tools which I have already covered, and I will be covering in future video. If other tools I've missed, I know I haven't done so, but this is a very renowned tool, that's why I'm covering. So before let you go, so let me give you a example. Say for instance I want to open a Wikipedia page, just because I'm going to show you how the complex internals look like with a complex browser itself is a very complex stuff, right? So I have shown you the simplest possible example by running cat against the Strace binary, and you saw a lot of output coming out. If I run a browser, it certainly overwhelms sometime, but let me do it for the sake of demonstration. I try to open a page in the Wikipedia, which is essentially a Linux Wikipedia page. If I write Linux and it's going to open the Wikipedia page of Linux, right? So now if I go back here and trace, all I have to do, I open this Wikipedia page in a browser called VIMB, a browser based on Vim concept. Underneath it is running WebGTK. Okay, I have mentioned it many times and make a video out of it, and if you go back to the channel and find it out. Anyway, this browser page on the right hand side open in a browser called VIMB. So I'm going to trace out the process, what is going on underneath. Okay, so to do that, I run Strace -p to get the process ID of the particular process. Okay, all I have to do, get the PID of it, right? PID of VIMB. Okay, so if I run this, it will show me how the tracing underneath working when I invoke or access or whatever is going on underneath. Okay, so it's saying it's operation not permitted. That means it require to access some area where the super user privilege is mandatory or required. So if I run sudo bang bang, which is used to run the previous command which require super user authentication. So if I write the password, see, it is so it is tracing. See, it started to tracing what is going on underneath. Okay, it's more complicated in the, as I mentioned, browser is a complicated piece of software. Any damn browser. Most of the people don't realize or never wanted to realize that how complicated it is to represent stuff on the browser itself, because underlying that lots of things going on. Okay, so I have just opened an ordinary Wikipedia page and it will show you some other system called write, few takes, okay, poll, read. Okay, these are the system called. You can easily see what is going on. Okay, by writing a Strace -e, then if you write write or read or whatever the system call you want to see, it will show you how it is behaving. So it's a damn useful tool if you spend some time to see all this stuff. So it will help you. It will help you to understand what is going on underneath. So you might come up with it will certainly enhance your understanding to how things work under the hood. Okay, so this is a very brief video about a Strace which will assist you in debugging or allow you to see what is going on underneath. Okay, I hope this will be useful for some people. Thanks for watching.